As an animation student, I require relatively powerful hardware to be able to work adequately and rendering my projects as quickly as possible. Luckily, my friends have finally begun to see the value in having faster render times when it comes to 3D projects in particular, and they've finally caved. So now, I can welcome you all to our second PC build of this channel, the Budget 3D Modeling PC. Here's a disclaimer. We bought all of these parts during the time where the graphics cards were obnoxiously expensive, so we had to cheap out a little more than what we would have on the graphics card considering the ridiculous pricing. Also, we built this PC months ago, but we wanted to wait at least 3 months so that we could have a longer term evaluation of this hardware and how it's held up with our current workload. With that out of the way, let's begin. Our processor of choice is the Ryzen 7 1700 CPU. In general, I've noticed that these Ryzen CPUs are pretty fantastic for content creation and 3D work, as these are all multi-threaded workloads and we are getting a great core count of 8 with 16 threads at a great price. Next is our GPU, mostly of choice. PNY's GTX1060 3GB. We got lucky enough to find this on eBay for $300 at the time, which is the normal price of the GTX1060 6GB, but that one costs upwards of $400 due to the GPU issues our community experienced not very long ago. This was our best bet, considering the circumstances, but we do plan on upgrading eventually. We decided on 16 gigs of DDR4 RAM because RAM was also crazy expensive, and quite frankly, 16 gigs will do just fine for the kinds of projects my friends will be working on, so we settled on that. We went for the MSI X370 motherboard, as we weren't really looking for anything with a lot of bells and whistles. This is a rather simple motherboard which can hold 4 sticks of RAM, which will be great for the future. As for the power supply, we went for EVGA's Supernova 750-watt bronze model. I've grown to trust their power supplies as they've always been very reliable, and that even accounts for the bronze models. We won't be utilizing all 750 watts, but it'll leave us open for upgrading the rest of the parts without having to change the PSU in the future. We decided to go for a water cooler for this build, as the CPU is expected to be under very heavy load while working on 3D renders, even though Cinema 4D supports GPU rendering. This unit will continually keep the Ryzen 7 properly cooled. This is the Corsair H100i. For our storage solutions, we went for the simplest drives we could find as he values quantity over velocity. So we just went for 1TB WD Blue drive for mass storage and a 120GB Kingston SSD for storing the OS and important software. Any SSD for booting into Windows is better than just using a mechanical drive. Lastly, we've got the case. This is the NZXT Phantom 410 mid-tower case. He likes the color scheme and it's a good size for the hardware we are storing inside, so why not? First, we unpack the motherboard and place it over the anti-static bag it comes in. This is where we will be installing the CPU and RAM before screwing it into the case. When installing the CPU, we lift up the retention arm and then make sure to align the golden triangle on the CPU with the same emblem on the socket. We gently place the CPU in the socket and then give it a small jiggle to make sure that it is well seated and then lower the retention arm. Now we have installed the CPU. As for installing the RAM, we first lift the retention clips from both sides of the memory modules. Then we insert the RAM stick through the corresponding entry from one side and then press down. We are going with a dual channel configuration, so we are placing the RAM sticks on the modules of the same color. Upon completion, we're done installing the RAM. Now we can proceed to open up our case. Since we are installing a water cooler later on, we have to secure the spot where the water cooler will go. We will have it on the very top of the case, which means that we have to remove the top panel for us to be able to work. Both of the side panels will have to go as well since we need them all. We had a lot of screws to undo, but we are ready to continue. Before installing the motherboard, we have to install the I/O shield. Before starting, make sure to align the I/O shield with the motherboard ports to make sure that they have the same orientation. We will begin by inserting it from the inside, as it'll pop into its correct placement once I apply enough pressure. With that installed, we can finally install the motherboard. Before screwing in the motherboard, we are going to screw in 8 motherboard standoffs on the corresponding holes. Then we gently place the motherboard over the standoffs while correctly aligning them together, and finally screwing it in from all sides. We want to be gentle, as if we tighten the screws too much, then the motherboard could flex. Now we've installed the motherboard. Before installing the radiators, we have to remove the included fan from the top of the case because we will be installing new ones. Now, we place a radiator on top of the case while making sure that the tubing can pass through the inside of the case. And then we screw in both 120mm fans through the inside of the case, so that they will stay attached to the radiators on top. Now we can go ahead and close the top portion of the case, screw it in, and we're done installing the radiators. The cooling block itself will be next. We begin by unscrewing the black brackets right beside the CPU. Then we attach the appropriate screwing bracket into the water block. And even though this already comes with pre-applied thermal paste, we will add another bit of about the size of a grain of rice on the CPU before gently placing the cooling block over it. Then we screw in the cooling block until it is consistently making enough contact with the CPU. And that's it for the water cooler. Now we're going to install the power supply. We will begin by inserting it from inside of the case and screwing it in from outside of it. The power supply is in, but we have to plug in the cables later. Next is the graphics card. We will begin by unscrewing the brackets where the GPU will be placed on so that the ports can remain open through the back, and so we can screw in the GPU properly. We will lift the retention clip from the side of the port, and then we will place the GPU on it. We will press down gently from the unclipped side of the port first, and then we will place it down completely. We screw in the graphics card from where the brackets were, and we've finished installing the graphics card. Now we've got the storage. We will install both the HDD and SSD through the storage brackets on the side of the case. The HDD will be screwed in from all sides of the bracket so it is nice and secure, and then we will slide it back into the case. The SSD is a bit of a different story. Due to it being so much smaller, we will have to screw it in from the bottom and maybe add a screw or two from the side to keep it as secure as possible. Then we slide it back into the case, and that is that. At this stage, we start plugging all of the power supply and case cables into the corresponding sides of the motherboard. It is a long process, likely longer than the build itself in most parts, as we need the instructions manual for the motherboard so we can see which specific components would go where. After that whole process and doing a little bit of cable management, we can finally put the case back together. We will screw in both side panels, of course, after testing this PC, and to see if it will power on and boot. And boot it did. Booting into Windows was a breeze. The SSD, even months later, is able to keep up just fine, and within seconds we are ready to use this PC. All of our testing will consist on this PC's performance in Cinema 4D. Performance within the software has remained smooth for the past few months. I'd argue that performance within the program is just as important as render times, as we cannot afford to have any hiccups while working, or many of them for that matter. We were able to work on textures more extensively and make more complicated shapes. This is Robert's baby tiger crab, his final project from our 3D animation course. We worked on rigging his creature to animate him as a playful being that could viciously attack those who threaten it. We only needed it to be 6 seconds long, 30 frames per second. Working on this machine has been incredibly smooth, and it can handle having a lot of assets on screen at once. This sequence, as I just explained it, was rendered out in MP4 format at 1920 by 1080. This 6-second sequence took 9 minutes and 48 seconds to render out fully, which is a massive jump in speed in comparison to his previous work machine. This project was a success. With that said, he's going to try to take advantage of the power of this PC in other ways. That's when a game like Final Fantasy XV will come into play. This game ran at a steady 60 frames per second in mostly average settings at 1080p. Most bells and whistles were turned off, but this is a very demanding game and it still runs quite well on the system. Certainly much better than what the PlayStation 4 or Xbox One can push out. So for that reason, this project was also a success. We have finally reached the conclusion to this video. This system is a great way of getting into 3D modeling if your budget isn't very large. With about $1,000, you can have a system that not only can render 3D projects with a moderate amount of layers and textures and even an animation in little time, and will serve as a fantastic entryway to properly being able to work on developing your animation skills. We did end up having to spend more than $1,000 due to the inflated pricing, but overall, this build was very well worth it. For more content, make sure to subscribe to our channel, and to stay updated when a new video comes out, make sure to click on that bell and enable notifications. Links for everything featured in this video will be found in the description, as well as links for what to watch next. We will also make sure to include an updated price list for everything featured in this video. This has been Francisco from Tech Summit. Thank you for watching, and I'll be seeing you all later. Enjoy.